All right, this was the first lesson that we looked at where we needed to solve radical equations. And we began by just looking at and discussing these first two equations, numbers 1 and 2, and trying to identify what steps were taken to solve. And we noticed that in both cases you began by isolating the radical, then squaring or cubing or raising both sides to the fourth power, depending on what the root was, to get rid of the radical. Then you would continue to solve for x, and then the last and most important is to check your answer to make sure that it's not an extraneous solution, okay? So after that, we went straight into 3 and 4, where we had to solve both of these equations. You subtract by 6, get -2. When you square both sides, you have to include parentheses, so this gives us x equals 4. But the problem here is that when you check your answer, the square root of 4 plus 6 does not equal 4, which means that 4 is what we would call an extraneous solution. It's a solution we obtain by following all the correct mathematical steps, but doesn't actually make the equation true. So since this is the only answer we got and it's not true, then there is no solution to this equation, which we can represent with empty curly brackets or that symbol, which also means there's no solution. Okay, let's do the next one. Same idea, we subtract by 6, get the cube root of x equals -2, cube both sides, and get x equals -8. When we check this, it works out because the cube root of -8 plus 6 does in fact equal 4. So that is our solution. Okay, now, something else that we addressed, which is important to talk about now, is the fact that for number 3, we didn't have to go through the entire process solving for x in order to realize that this has no solution. All we had to do was isolate the radical and analyze the equation. If you have the square root of x equals -2, the square root of any number will always result in a positive value. For example, square root of 36, 6, the square root of 81, 9, and so on. There is no value that I could take the square root of that would produce a negative number, right? In this case, -2. So you're basically saying that, or at this point, you basically realize that because there's no value for x that will ever make this true, this has to have no solution. Okay, let's keep going with the next one. Same thing, I want to solve and then check my solution. So start by isolating the radical, add 2 on both sides, square both sides, subtract by 5, divide by 3, check your answer. So this is going to give us -4. Square root of -4 plus 5 is square root 1. Square root of 1 is 1. And -1 does equal -1. So that's our solution. Okay, moving on. Now we did a couple other problems. I'll go through these relatively quickly. And same thing, we want to make sure to check our answers at the end. So square both sides, you get 121. Add 3, 124, divide by 2, you get 62. And then when you plug that back in, you get a true equation. I won't show the work for that. Just you can check it on your own, or you could just trust my answer. So final answer is 62. Let me move to this side. cube both sides. I'm going to do something else. I'm going to move x to this side, and I'm going to move 27 to that side. So I get x equals 33. That also works out when I plug it back into the original, so that's the solution to that equation. Here, add 9, you get -3. At this point, I personally would stop because I recognize that the square root of whatever x plus 5 is cannot ever equal negative, so this has no solution. If you didn't realize that though, and you continued to solve, you're just going to get something that isn't true. You're going to get a false equation. So the square root of 9 minus 9 does not equal -12. So that's how you know that can't be the solution. Okay, moving on. Square both sides. Get 4x minus 7 equals 3x plus 9. Subtract by 3x. Add 7. That works out when you plug it back in, so 16 is the solution. I know I'm going through these quickly just because we already did some of these, and these are the easier ones. Divide both sides by -12. That gives you the square root of x minus 6 equals -3/2. Again, you could stop here and say no solution because of the fact that the square root equals a negative number, but if you were to keep going, you'll find that you just get an extraneous solution. Now, when I add 6 to the right, I'm going to have 6 over 1, which I'll convert to 24/4 so that I can combine the two fractions, and that's going to give me 33/4. But when we check, -12 times 33/4 minus 6, which I'll convert to 24/4, does not end up equaling -18. So 6, 9, when we subtract, -12 times 3/2 could not equal 18. So that means that's extraneous and there's no solution. Moving on, divide both sides by 3. Get cube root of x plus 2 equals 4. Cube both sides. You get x plus 2 equals 4 cubed is 64, so x equals 62, and that is the solution. Moving on to 11, square both sides. You get x squared minus 5 equals 4, add 5, get 9, square root both sides, and remember that whenever we do that we add plus or minus, so that gives us plus or minus 3, both of which work out when we plug them into the original, so those are both the solutions. Moving on to 12, you square both sides. This is quadratic, so move everything to one side and factor. Two numbers that multiply to -9 but add to 8 are +9 and -1. Set both equal to 0, and you get x equals -9 and 1, both of which work out and are solutions to the equation. All right, moving on. This I assigned for homework, but I'll talk about it right now just so that you guys can check your answer with the video if you get confused. You want to compute each product and then combine like terms at the end. So looking at these two factors, root x plus 2 times root x minus 2, something that would be helpful to notice is that these are conjugates of each other. They're basically the same, just opposite signs. So when we distribute or FOIL, we don't have to do every part, we just do first and last because the outer inner parts will always cancel each other. So root x times root x is equivalent to root x squared, which is just x. And then outer would be -2 root x, inner would be +2 root x. Like I said, we don't need to do that because these will cancel each other. And then last, +2 times -2, negative 4. And there are no like terms to combine, so that would be the final answer. Here, these aren't conjugates because they're literally the same. So in other words, this is equivalent to the square root of x plus 4 squared. So when I multiply this out, I do all parts of FOIL. So square root of x times square root of x is just x. Outer and inner are the same, so I can combine those like terms to get 8 root x, and then last 16. So x plus, let me write it nicer, x plus 8 root x plus 16 would be my final answer, and none of those are like terms, so that's just what it is. Moving on. Same thing. Here, this is equivalent to the square root of x minus 5 squared because it's the same quantity times itself. In which case, you could just literally negate these two, and you're just left with x minus 5 as your final answer. Okay, why is it useful to know that? Because sometimes when we're rationalizing the denominator or solving equations, we need to be aware of how to multiply out expressions that contain radicals. So here, if I wanted to rationalize the denominator, how do I get rid of the radical? Is it this type of scenario? This didn't get rid of the radical, so it could be 15 or 14. Either one of those would be useful to know. If I want to get rid of the radical in the denominator, I need to multiply top and bottom by root x minus 9. Okay? So the reason why is because when I do that in the denominator, I'll get x minus 9 squared, which is going to end up canceling to just be, well, the radical and the power of 2 will cancel to just be x minus 9. In the numerator, I'm not going to multiply it out. I'm going to leave it in factored form, because if I look at the denominator, I'll actually be able to cancel x minus 9 with x minus 9, and so we're just left with the square root of x minus 9 as the final answer. B, again, if I want to get rid of the radical in the denominator, I'm either looking at a scenario like 13 or 15. In this case, only the x is under the radical, so it's a situation similar to 13. In A, both values were under the radical, so that was similar to 15. So in this case, I need to multiply top and bottom by the conjugate, so root x minus 3. When I multiply that out in the denominator, remember I don't do every part of FOIL, I just do first and last. So first I would get x, last I would get negative 9. And in the numerator, again, I'm going to leave it in factored form, only because I recognize that those divide into each other, and so we're left with x minus 3 as the final answer. Okay, moving on. Rewrite this fraction in an equivalent form with a rational expression in the denominator. So, in other words, rationalize the denominator. So I have 1 over root x minus 5. I need to multiply by the conjugate, since there's two terms and only one of them has a radical. In the numerator, I'd have root x plus 5, and the denominator x minus 25. And that's all you would do there. Okay, 17. In this case, I want to not only isolate the radical to solve this equation, but I also need to get it out of the denominator. So the easiest thing to do is to think about cross multiplication, or to just multiply by root x plus 3 on both sides of the equation. So I take the equation and just multiply both sides by root x plus 3. The reason why this is helpful is because these will cancel, so I'm left with 3. And then 1 times root x plus 3 is just x plus 3. And now this is a very similar equation to the previous problems we've done. And you get x equals 6 as your final answer. And if you plug it back into the original, it does check out. So that's your final answer. All right, without solving the radical equation, root x plus 5 plus 9, how could you tell that it has no real solutions? Well, if I move the 9 to the other side, I get the square root of x plus 5 equals negative 9. Again, the square root can never equal a negative value, so that's as far as that goes.